All right, tonight what I'm going to talk about is dilutions. And a lot of people kind of have a vague understanding what a dilution is or if something is dilute, but they don't know the technical terms. In a dilution, the amount of solvent is increased, which means the stuff that it's dissolved in, so the water or the liquid typically, but the solute, so the number of particles, is kept the same. Therefore, you have a lower concentration but a greater volume. So what I'm going to do right now is draw you two pictures, okay? So both of them are going to be dilute solutions. So in the first picture, what we're going to have is we're going to have our little particles, and our particles we're going to have, let's say, 6 particles. And so we have it in a solution and we fill it up and it fills up to this line. Now what I'm going to do is I'm going to add more of the liquid substance. So by adding more, what I'm going to be doing is I'm going to be raising the volume. But if I look at the individual particles, I had 6 particles originally, and so because I didn't add any more of those, I am just going to have still 6. They're just going to be spaced out more. Therefore, this second solution is more dilute than the first solution because the number of particles stayed the same, but the total volume increased. That is one type of a dilution. Another way to do a dilution is to have a substance, okay? So we've got a substance, and let's say per amount of volume, and I'm just going to draw 2 lines of volume just to say that those are the different segments. We have on average, let's say 3 particles. So I draw my 3 green particles per individual amount of volume. So that's its density, or that is its concentration, its molarity. And we'll just regularly define this as we have 3 molar. So we're going to say, hey, it's 3 particles per liter. Now what I'm going to do is I'm going to pour one of those solutions into another beaker. So I'm going to have another beaker, and I'm going to pour one of those, or half of it, into this, which right now, because I just poured it from one glass to another glass, I'm going to fill it up to that line. I am going to still have only 3 particles. 1, 2, 3. So at this stage in the game, both have the same concentration. Okay, why? Because I have 3 particles per little section here, and I have 3 particles per section here. Now what I'm going to do is I'm going to dilute it. And how you dilute it is you are going to fill it up. So this is going to be the same container, okay? But what I'm going to do is add more liquid, okay? So the water or level, the liquid level is going to rise. But did I add any more of those green particles? No, I did not. So I would still only have those 3 particles. So it would be 1, 2, 3. So in comparison, if we look at picture number 1 versus 2 versus 3, my number 1 and 2 is the same concentration, but the change to 2 to 3, it is now a more dilute solution. Okay, why? Because this, in 1 and 2, the particle amount per amount of space is the same, whereas in 2 and 3, even though the particle number stayed the same, the volume increased between 2 versus 3. Now what you're going to need to do for dilution formulas is you are going to use the formula M1V1 equals M2V2. Now note for this one, unlike the molarity formulas, your volume units are they don't give you a specific volume unit that you need to use. They just need to be the same. So if I start with milliliters on one side, I need to end with milliliters. If I start with liters, I need to end with liters. This is unlike with the molarity calculations where you had to always be in liters. So let's go and do some practice problems. All right, if you have 22.5 milliliters of 2.0 molar, so notice that word of, okay, that is a key, that is possession. So what that means is that those two are linked together, okay, of copper 2 sulfate, and dilute it to 250 milliliters. So that is its own separate volume. What is the concentration, meaning molarity, of the final solution? What I like to do is I like to, above each of these problems, what I like to do is label what I'm given, okay? So because I know 22.5 milliliters and the 2 molar stock solution go together, I am going to label those in my brown color. So we've got our volume 1 and our molarity 1, okay? And then I know that I'm diluting it to 250 milliliters, which is a volume unit, so there's volume 2. And then it asks for concentration, so I am going to figure out what M2 is. It does not matter in the formula what you assign as M1 or M2. What does matter is that you align molarities with the correct volume on each given side. So now what I'm going to do is I'm going to do the formula of M1 V1 equals M2, V2. And so now solving this, I've got M, which is 2.0, times my volume, which is 22.5. Notice that I am keeping it at 22.5 milliliters. It's absolutely fine in this case because I'm going to be using milliliters on the other side. Notice that those two are the same units. My final volume is, or my final molarity is what I'm trying to solve for, and I'm going to times it by my final volume, which is 250 milliliters. All right, so when I solve this, I need to round to 2 sig figs, so I get 0.18 molar solution. All right, the next one. What is the final molarity? So in this case, I'm asking for M2. So my final molarity of a solution made when 380 milliliters of 0.48. So now because I see that of, I know that those two numbers are together. And so this is my volume 1, and 0.48 is going to be my molarity 1, and is diluted to a final volume, okay, which would be a volume unit, so that would be my V2 of 800 milliliters. I'm going to quickly check to make sure that my volume units are in the same, and I have milliliters in one, and I have milliliters in my other one, so I'm absolutely fine with that. So now I'm going to use my formula of M1 V1 equals M2 V2, and I'm going to do 0.48 for my M1 times my V1, which is 380 milliliters. Sorry, you should be putting molar right here. And that equals my molarity, so M2, and my V2 I'm given, so 800 milliliters. And what I need to do is just quickly solve it, and solving and rounding to the correct number of sig figs, which is 1, I get 0.2 molar. So now looking at example 3, it says how many milliliters of 0.85 molar solution do I need to make 450 milliliters of 0.2? So looking at my possession, I know that these milliliters and that molarity go together, and the 450 milliliters and the 0.2 molar go together. Okay, so once again, it doesn't matter what I'm going to assign as M1 V1 or M2 V2, but I see that I'm given milliliters. Okay, so I'm going to say that that milliliters is volume 2 of 0.85 molar, so I know that that's got to be my M2. I look at the 450 milliliters, which is my V1, of my 0.2 molar, which is M1. So once again, it doesn't matter which one you assign as M1 or M2, but they need to, the possession needs to go to together correctly. So the molarity needs to go to its corresponding volume. All right, so now plugging into my molarity my M1 V1 equals M2 V2. I have my M1, which is 0.2 molar, times my V1, which is 450 milliliters. Okay, that is equal to my M2, which is 0.85 molar, times my V2. All right, so now solving this, I end up with 100, rounding to the correct number of sig figs, which is 1. I end up with 100 milliliters, okay, equals my V2. How did I know that it would be in milliliters? Well, if I look at my volume on the other side, that unit is in milliliters, so whatever volume unit I used on the other side is what volume unit I need to be in on the other side, so that would also have to be in milliliters. All right, hopefully you understand a little bit more about dilutions, and we'll be practicing them during class.